Welcome to the deep dive. Look, if you're operating in the cloud, you already know keeping up with Azure updates is, well, it's relentless. It feels like a full-time job sometimes.
It really does. The pace of innovation is just incredible.
Exactly. So we're here to do the heavy lifting for you. We parse through the noise, distilling the key Azure announcements from November 3rd to November 7th, 2025, into what you actually need to know.
Yeah, turning that fire hose of information into something actionable.
Precisely. And our mission today, it's squarely aimed at the technical listener. We've sifted through everything and pulled out 18 really impactful GA and public preview features. We're talking analytics, storage, databases, networking, the stuff that directly impacts you if you're an infrastructure architect or a lead developer. We're going deep.
And it was a dense week. Seriously. Just listing 18 updates isn't helpful though, right? So our goal is to group these by theme. We want to look for the underlying trends. How are these updates changing how we should think about infrastructure design? What's happening with developer tooling, especially with AI creeping in? And maybe the biggest one, how is all this bolstering workload resiliency?
That makes sense.
Oh,
Let's start then with analytics and graph querying. Seems like a good place. There were two key updates for Azure Data Explorer ADX and Fabric Event House Graph Semantics.
right. First up, in public preview, we've got openCypher support for KQL graph semantics.
Okay, openCypher, that's the big open source graph query language, isn't it?
Exactly. Super widely adopted. So bringing this into KQL environments like ADX or Fabric Event House is a pretty big deal. It simplifies things massively if your team already knows Cypher. They can jump right into Azure's analytics engines without, having to learn a whole new syntax from scratch. Just lowers that barrier to entry.
Yeah, that's a potential game changer for teams already invested in graph. Saves a ton of time in retraining. Okay, what was the second analytics update?
The second one is now generally available, or GA. It's the labels function in KQL graph semantics.
Labels, so this helps with managing graph data.
Precisely. Before this, working with labels on nodes and edges could be a bit cumbersome. Now, with labels being GA, you can easily retrieve, filter, project that label information right within your query. Think about complex graphs, maybe dependency mapping or large identity systems. This function makes it much, much easier to slice and dice that categorized data without pulling back more than you need. It's about efficiency.
Got it. More precise querying for complex graph structures. Okay, let's shift gears then, moving from analytics to storage. The theme here seems to be control and resilience.
Definitely. Starting with UltraDisk, we now have general availability for its new flexible provisioning model.
Flexible provisioning. What does that actually mean for someone using UltraDisks?
It means you can finally configure capacity, IOPS, and throughput the MBPS more independently. This is huge. Previously, these were kind of locked together. You might have needed high IOPS but not much capacity, yet you were forced to pay for extra storage you didn't need just to hit that IOPS target.
Ah, right. I've definitely run into that problem, paying for capacity just to get the performance.
We all have. This new model lets you fine-tune each aspect separately. Tailor the performance exactly to your workload's needs, which directly translates to better cost optimization. No more over-provisioning just because the metrics were tied together.
That sounds genuinely useful.
Yeah.
Okay, sticking with storage, but moving towards HA and monitoring. Blob storage got object replication metrics, now GA.
Yes, and this is crucial if you rely on geo-redundancy for your blobs. Monitoring replication used to be a bit of a black box,
You set it up and hoped it was working.
Pretty much. Now, these metrics give you real visibility. You get data on pending operations, pending bytes. You can actually see if there are replication delays, troubleshoot bottlenecks effectively, and, importantly, prove that your HA setup is working as expected. It builds trust.
Okay, that visibility is key for critical data. And speaking of proving things work, planned failover for Azure Storage also hit GA. You mentioned this is customer managed.
Right, customer managed, which means you initiate it. The core benefit here is validated, predictable resilience. You can manually trigger a seamless swap between your primary and secondary storage endpoints in a geo-redundant account.
Seamlessly, while keeping the data safe.
Exactly. It maintains data durability throughout the process. This is vital for things like mandatory DR drills or planned maintenance or even migrating regions. You can test your failover plan or execute a planned move without disruption and without losing that geo-redundancy safety net. Makes sense. Being able to test confidently is huge for DR. Okay, one more storage item before databases, a preview feature for Azure NetApp files, the Object REST API. Yeah, this is interesting. It's an S3 compatible REST API for Azure NetApp files, ANF.
S3 compatible, so it makes ANF look like object storage.
Essentially, yes. It builds a bridge between that traditional high-performance file storage world of ANF and the modern cloud object-based ecosystem. Data in ANF can now be accessed using standard S3 protocols. This opens up a lot of new possibilities, especially for integrating ANF data with platforms like Microsoft Fabric or other services that expect an S3 interface. It really broadens how you can use that ANF data. Okay, cool. So storage this week. More granular control, better visibility for replication, predictable failover testing, and bridging file storage to the object world. Good stuff.
Let's pivot now. Developer productivity, databases, and AI. The big headline seems to be the public preview of GitHub Copilot in SQL Server Management Studio, SSMS.
Yeah, this one got a lot of attention. And it's more than just adding autocomplete to SSMS. Sure, Copilot helps you write T-SQL faster and hopefully more accurately.
Right, the usual Copilot benefits.
But the really interesting part, the potentially revolutionary part, is that it uses your database and connection context to answer general SQL questions. It's looking at your actual schema in real time to give you relevant suggestions.
Hold on. If it's using my database schema context, what about security? Compliance? Are we sending proprietary schema info somewhere we shouldn't be? That's the first thing I'd worry about.
And that's absolutely the right question. Microsoft's communication emphasizes that it's designed to use this local context securely. But look, with any AI assistant, especially one touching your data schemas, diligence is key. Engineers have to understand where that context is processed. And critically, you still need to rigorously validate any code it generates. Don't just trust it blindly, especially around data privacy or access controls. The AI is a helper, not a replacement for careful review.
Okay, so caution and validation are still paramount. Good advice. All right, moving from AI assistants to direct query performance, we saw the GA of Query Advisor in Azure Cosmos DB for NoSQL, specifically for the .NET SDK.
Yeah, this is pure performance tuning assistance. It automatically analyzes your query structure within your .NET application and gives you clear, actionable tips to make it faster and more efficient. Think about identifying missing indexes or suggesting better ways to structure the query itself. For anyone running high-throughput Cosmos DB apps where latency matters, having this kind of automated advisor baked in, it's potentially invaluable for shaving off milliseconds. Anything that helps tune Cosmos DB queries is usually welcome. Okay, also in Cosmos DB, a geospatial update went GA. Orderized distance for NoSQL geospatial queries.
Right.
This lets you do distance-based sorting directly in the database engine.
Instead of pulling data back and sorting in the app.
Exactly. Previously, you might have fetched a bunch of results based on location, then calculated distances and sorted them in your application code. Now you can just add order by assess distance to your query, referencing a specific point or a GeoSON object, and Cosmos DB handles the sorting natively. It simplifies your application logic quite a bit and should significantly improve performance for location-aware features. Much cleaner. Nice. Less work on the ACK side, faster results. Okay, one more in this developer database space. The announcement of the Document DB Kubernetes operator. This sounds like infrastructure as code territory. It absolutely is. This is an open source operator. Document DB itself is that Mongo-compatible database built on PostgreSQL. This operator lets you run and manage Document DB natively on Kubernetes.
Using CRDs, I assume. Custom resource definitions.
Yeah,
exactly.
It extends Kubernetes using CRDs. So if your organization is already managing applications, deployments, scaling, all that stuff, using declarative Kubernetes manifests, now you can manage your Document DB instances the exact same way. It brings Document DB lifecycle management into that standard Kubernetes workflow, giving you a unified control plane. It's about consistency in management.
Makes sense. Manage your database like any other K8s resource. Okay, let's transition again. High availability and disaster recovery for managed relational databases. Storage choices seem key here.
They often are. For Azure Database for PostgreSQL Flexible Server, there's a new public preview. You can now configure read replicas using Premium SSD v2, and this applies to both in-region and cross-region georeplicas.
Premium SSD v2. That's the high-performance tier, right? So faster read replicas.
Exactly. If you have really demanding read-heavy workloads, maybe for reporting or analytics offloads, you need those replicas to be fast too. This lets you use the top-tier storage for replicas, ensuring performance isn't compromised when you scale out reads.
Got it. And sticking with PostgreSQL resilience, there was also a GA announcement for flexible server availability zones expansion in Japan West.
Yeah, this is about regional infrastructure depth. Architects deploying in the Japan West region can now spread their PostgreSQL flexible server deployments across all 3 available AZs there. It provides that much more robust, highly available setup that can tolerate the failure of an entire availability zone within that region. It's fundamental HA. Okay, now for MySQL. Azure Database for MySQL Flexible Server got a GA feature, a dedicated Azure Standard Load Balancer. What's the significance of it being dedicated? The dedication ensures resource isolation and predictable performance specifically for the high availability mechanism of your MySQL server. By having its own standard load balancer, you avoid potential noisy neighbor problems or resource contention that might happen with shared networking components. It means that when a failover actually occurs, the network path switching to the new primary server is expected to be faster and more reliable.
So it removes a potential variable during a critical failover event. Makes sense. And finally, in this HADR segment, a preview update for Azure SQL Hyperscale supporting multiple geosecondary replicas.
Yes, this is a big one for hyperscale DR. Previously, you typically had one primary and one geosecondary. Now you can configure multiple geosecondaries in different regions. This drastically simplifies designing more complex, multi-region disaster recovery topologies for those very large hyperscale databases. You get more redundancy options and potentially faster recovery points depending on your architecture.
More flexibility for complex hyperscale DR.
Good to know. Okay, let's shift one last time. Hybrid networking, specifically ExpressRoute. There was a trio of GA features all focused on network reliability.
That's right. It's all about monitoring, assessing, and validating the resilience of those critical hybrid connections. First, the GA of Monitor end-to-end ExpressRoute connectivity with Connection Monitor integration.
So making monitoring easier to set up. Exactly. It streamlines the process. You can now enable Connection Monitor for end-to-end path monitoring directly when you're creating or updating your ExpressRoute connection in the portal or via automation. It removes some manual steps that used to be quite tedious. Okay, easier setup. Then there's the assessment part. GA for ExpressRoute Resiliency Insights. You mentioned a resiliency index. Yeah, the resiliency index. Think of it as a percentage score, a quantifiable measure of your ExpressRoute setup's resilience. It looks at factors like how your routes are configured for redundancy, whether you're using zone redundant gateways, things like that. It moves you from just hoping your connection is resilient to having an actual metric that assesses its health and reliability for your hybrid workloads. It gives network architects something concrete, a score. Interesting. And to prove that score means something, the third GA feature, ExpressRoute Resiliency Validation. This is the ACT testing piece. It actually lets you trigger site failovers for your virtual network gateway connected to ExpressRoute. You can simulate a failure and prove that your network remains available for your workloads. So you've got the monitoring setup streamline, an index to assess the theoretical resilience, and now a GA tool to actively validate it under simulated duress. It's a complete suite for operationalizing ExpressRoute reliability.
Monitor, assess, validate. Makes sense. Okay, we've covered 17 updates now, but the last GA announcement feels different, foundational maybe, the Azure MCP server. It's based on something called the Model Context Protocol. Why is a new protocol standard like this such a potential shift?
It is a potential shift, and maybe a massive one, because it tackles the inherent complexity of modern cloud architectures, which are increasingly made up of many distinct interconnected services. The Model Context Protocol, or MCP, and this new Azure MCP server built on it, essentially create a secure, standards-based communication fabric between different Azure services.
A fabric, like a communication layer.
Exactly. Think of it as a kind of unified API or bus that lets traditionally siloed services like AKS, Azure Container Apps, App Service, Cosmos DB, SQL, even AI Foundry securely and instantly share runtime context with each other.
Okay, context sharing. Why is that the crucial part? What does sharing context actually enable that we couldn't do before?
It enables smarter, more autonomous systems, especially as we move into an era of AI-driven operations and sophisticated agents managing cloud resources. Think about an AI agent trying to manage a complex application. Right now, it might need to make dozens of separate API calls to different services just to figure out the current state, the context of the whole system. It's inefficient and slow.
Right, API calls everywhere just to get a picture.
The MCP server provides a single standards-based bridge for that context. It gives agents, or any component that needs it, a holistic, real-time view of the relevant parts of the system state. They can move beyond simple single API interactions to actually orchestrating and managing the entire multi-service environment more cohesively because they understand the broader context. It's potentially redefining how automated management and even applications interact with the cloud platform itself. It's giving agents, as they say, the power of the cloud through shared understanding.
Wow. Okay, that does sound like a fundamental shift in how things might work. So let's try and synthesize then. Looking back at these 5 days, November 3rd to 7th, what's the big picture? I think a clear pattern emerges. Microsoft seems laser-focused on really 3 core areas this week. First, granular control. We saw that with the flexible ultra-disk provisioning, the customer-managed planned failover, giving users finer knobs to turn.
Okay.
Control. What else?
Second, superior observability, making black boxes transparent. The object replication metrics are a prime example, as is that whole express rate resiliency suite, the insights index, the validation tools, understanding what's actually happening.
Control observability.
And the third?
Third, AI-assisted developer enablement, boosting productivity and capability. GitHub Copilot getting context-aware in SSMS is huge. The Cosmos DB Query Advisor offering automated tuning tips fits right in there too, making developers faster and their code better. Granular control, better observability, and AI boosts for developers. That summarizes it well. These 18 updates, taken together, definitely offer substantial, real-world improvements in resilience, efficiency, and productivity for technical folks using Azure.
Absolutely. And maybe connecting it all back to that last big announcement, the Azure MCP server, establishing this standard for context exchange. It really makes you think. It suggests the next big challenge isn't just building these complex multi-service apps, but figuring out how to effectively manage them, especially using automation and AI. So the provocative thought I'd leave you with is this. What entirely new kinds of architectures become feasible, or even easy, when this shared context protocol acts as the unifying layer across your entire Azure deployment? What happens when all the pieces can truly understand each other in real time?
That's a fascinating question to ponder as you design your next system.